am Ana Carcedo. I'm fairly new at NDSU. I've been here 7 months only, and I have to say I'm really grateful for this opportunity. I've been learning so much from you guys, so much from the farmers, and I love being here. So today I'm going to be talking a little bit about the variety trials and how to use them. I actually choose this topic for all the Getting It Right. So if you had connected to the Getting It Right soybeans, you are going to see that I'm going to be reminding some of the concepts I mentioned before. So let's get ready. So just to start, when we're talking about sunflower, we're mainly talking about 2 types of sunflower. We have the one that's grow for oil, and then we have the confection. When we're talking about North Dakota specifically, we can see that most of the the sunflower that we grow is an oil type. The data I was showing before is from the sunflower survey, and I have to say that's an amazing effort that the National Sunflower Association does every 2 years. And it's amazing that how they really are interested in providing the updated information to their farmers about which is the condition. So that's really valuable information. And here what I'm showing actually is from the USDA. So it's how the acres and the production of sunflower had changed across the years. And even though we can see a decrease in acreage that we hope like next year with the good prices, it will change. We can see that actually the production, although it's variable, it had remained pretty much constant. And if we see the non-oil type, the confectionery sunflower, that proportion had remained quite steady. So saying that as oil type sunflower, it's more predominant. The rest of the presentation today, it's going to be more focused on oil type sunflower. Saying that, also from the sunflower survey, here are the latest sunflower survey was in 2023, so it's not from last year, but this can give you kind of an idea of which are the yield ranges across different states. And here you can see that it says average and median. This is how it was reported in the survey. And just for you to know, median is something that statistical people like, and it's basically you can order all your observations from the lowest to the highest, and the median is the value that falls just in the middle. And statisticians really like it because it gives you kind of an idea of the distribution. And hopefully the median and the average should be similar, but we are more used to talking about average, right? So when we're talking about North Dakota, again, we see that for 2023, the average yield was around 2,000 pounds per acre. Saying this, when we're talking about an average, and that's why statisticians use all other tools as well, it's like taking a picture from a movie. There is so much going on, there is so much information behind that average that we are not showing. So if, for example, if we see again, this is again from the sunflower survey, but now we are showing the maximum yield that we attained and the minimum yield that we attained in the different states, which showing the variation across the whole data set across all the observations. We can see that yield can be really variable. So if we go to the maximum in North Dakota, what we can see there is that we can attain up to 4,500 pounds per acre. So it's really different to that 2,000 that we saw before. Saying this is, okay, there is a lot of information. There is a lot of information that we have, even though I'm just showing average from a state, there is a lot of information that you as a farmer can have access to. And then it's important for me to talked about a little bit about how we have to interpret this agronomical data. And here is where I'm going to remind some of the concepts I mentioned in the last presentation, if you were here. So how we ensure that the data that we are using is reliable. So I'm from NDSU, and I have to say that if you use information from a university, you have that at least 3 things on your favor. You know that the university is not trying to sell you any product, so it's unbiased, and the results that we show is what we got. Then another thing that's really important is that we have information across the whole state. We have they call RECs, and that's just amazing. It's amazing information that actually not every state has that amount of sites across their states. So we have to be grateful to be here in North Dakota. Saying that, the last point is that when you work with information from a university, you know that there is some kind of rules from the experimental design that they are being followed. You know that the agronomists that work in the university, they are specialists on what they are doing, and they will do the things right. So I'm not saying a company won't do it right. I'm just saying that you can rest assured that if you're working with a university, you will have that risk covered. If we're saying this, I'm going to explain just a few concepts about this experimental design, and I know that this might be a little bit far from your everyday task, but I think it's so important that you get to know these concepts, just because if someone from other contexts comes and try to show you some results, you have the tools to ask to know if that information is actually robust and it's actually helpful, or it's just a demonstration and it doesn't actually give you the information that you want. So there is basically 2 concepts when we're talking about the experimental design that it has to be followed, and one is replicated. So in this case, this is just a diagram saying, okay, we have 3 different treatments, that there are 3 different colors, and it could be 3 different varieties that we are testing. And the important thing is that we don't have only one observation of each treatment or each variety. We repeat this. When we're talking about NDSU, and everybody has different protocols, and it actually really varies on what you are measuring. So we usually use at least 4 replications. If you are trying to measure something that's really, really hard to measure, you're going to use much more replicates. And then the other concept that is really important, it's, okay, that is randomization. So this is the thing. When you're doing experiment, what you want to see is actually the difference between the treatments. You don't want to see the weather difference or the field difference, but it's something that it's there and it's going to happen. So a way to try to deal with this variability that's not part of our treatment is randomized. So for example, in the diagram that I'm showing there, it's kind of a field. I put a gradient of color showing that, I don't know, maybe one part of the field is better than the other one. And when we randomize, is that we organize our replicates in a random way. And this way, we kind of cover all the idea of the variability. Saying this, there is other things that you should also consider, and is, okay, was this experiment replicated in different sites? Was this experiment replicated in different years? That gives much more robust information. So when you see any of the NDSU publications, you are going to see that everything is reported, like how many years, how many sites, how that was treated, if there was any problem during the season. So what I want for you is that the next time that someone shows you some experiments, some results from NDSU, or even from a company or from any source of information, check these things. Check ask how many replications they had, how many times this was done in different places, and this actually will give you an idea of which is the real value of this information. Saying this, I'm going to use this example that I used for soybeans, and it's trying to just showcase the idea of why just comparing averages sometimes can be misleading. So saying this, we have this random soybean experiment. It could be sunflower, it could be canola, it could be whichever crop you like the most. So in this, we are seeing that we have variety X and variety Z, and the variety Z have kind of a trend of having higher yields. But if we see the p-value, that's the probability that these are actually different, we see that it's 0.52. And this is not good. This is not good enough. Saying that, we are going to say, okay, even though they look different, they are not statistically different. And let's try to see what is happening behind this that is causing this difference. So if we see the raw data, we can say, okay, let's see the repetition 1. And when we see the repetition, the first repetition, we are going to see that the variety X and Z are actually pretty much the same. There is not much difference here. If we go to the repetition number 2, we are going to say that, okay, even the variety Z is a little bit higher, but again, they're not really different. If we go to the repetition 3, here we are going to see that there is a huge difference. And this should raise some questions to yourself. It's to actually trying to see why this is happening. Is actually the variety that is different, or it was something else going on there? There was some kind of topography differences, or there was an error in the measurement. That's something that could happen as well. And then if we go to the 4th repetition, again, they're pretty much the same. So basically that trend of difference that we can see in the green bars that it shows the average, it's mainly led by only 1 repetition, and it's not a really sound result. So that's why this is really, really important. If we are talking about how we analyze the data, probably this could be defined as an outlier and should be processed in a different way. But I'm not going to dig into that, and it's just an example to show you how this is measured. So basically, the take-home message from this slide only is, okay, a small difference, but significant, like when we're talking about like statistically significant, it's much more meaningful than if you have a large difference, but without statistically significant differences. So saying that, we are going to keep going. Something that I show you there, and I didn't really explain, is that it says CB there, and it's coefficient of variance, and it says 16%. So we are going to talk a tiny bit about this, and mostly because if you see any report, or even if you see our variety trial data, we always report CB. So it's good use for you to know what we are talking about when we are talking about this. So when we're talking about CB, it's just an idea of how these individual observations are actually close to the experiment average. So this sounds like a book definition, and it's hard to understand, so I particularly don't like it. I'm a really visual person, and I really understand things with diagrams. So I did this for you guys. So if we have a low coefficient of variation, that means that most of our observations are actually close to the experimental average. So it will be the first circle here, the first target here. But if we have a high coefficient of variation, that means that they are all over the place. They are not close to the target. So this is just like a representation. But if we try to see this with what it will look more like experimental data, it will look something like this. For example, we could have like experiment 1, where the average is 33. Everything is pretty much close to the average. It's not really different. They are all really close to that yellow line. But we can have an experiment number 2, where the average is exactly the same. The average is still 33, but we have much more variability. These values are much more further from this average. So it's an idea of how reliable your data is, how variable was within a treatment as well. So saying this, I'm going to talk a little bit about the variety trial booklets, and I'm going just to take 1 second to apologize. This is part of my new responsibilities in this job. Unfortunately, the sunflower variety trial results were delayed this year. And I just want to take 1 second to apologize about that. They are going to be available next week for sure. And then I'm going to keep going with the presentation now. I just wanted to make just 1 second for that. So, but as you connected, you are going to be so fortunate to have a preview of some of the data of the variety trial from the last year. So I just grabbed the information that was there, and I took Minot, Fargo, Hettinen, and Langdon, that were the more comprehensive data sets that they are included. And what I did is choosing the hybrids that are repeated in most of these, almost of these sites. And when we're talking about sunflower, and we're talking about sunflower with oil properties, the percentage of oil, it's really important. We want to be above that 40%. And we can see that there were more than a few hybrids that were below that. We're going to talk a little bit more about that later. And then the other thing that we usually check, and usually we check it within each site, you usually should go and check the site that is closer to your field. And if there is more than one, please check more than one. And if you have average data from different years, please check that as well. So when you're using the table, what you're going to actually check is if there is significant differences, as we were mentioning. But something that is also interesting, and more when we're seeing this data that's average across different sites, is just important to see if it is above or below the average across sites. So in this case, the average across sites was 2,100 pounds per acre. And basically what we are seeing here is that we have a fair amount that have a good variability above this value. Saying this, seeing the data like this is not really meaningful because we have all together. It's really interesting maybe, but it's not that meaningful. If you are in Minot, your environment will be completely different than if you're in Hettinger. But saying that, it's nice to see the information like this. So here I'm showing just the oil percentage in Minot, Fargo, Langdon, and Hettinger, and these hybrids were tested in all these locations. So all this information it's really comparable. Saying this, what we can see here is that there is some hybrids that have constantly above. They're constantly higher in their oil concentration percentage, and then there is some hybrids that they're constantly under 40%. So that's really meaningful information. Like regardless where you are, these hybrids didn't behave as they should. Moving forward, it's not only important to see oil, but it's also important to see yield. And here is where everything becomes a little bit more tricky. We can see that there is no many changes in ranking when we are seeing the oil concentration, but when we are seeing yield, this looks like a spaghetti, basically. We have all the lines crossing. Even though we can see that some of these lines actually are always below, and some of these lines try to be above. Saying this, we keep moving forward, and there is so many ways to see this information and to compare this information and to use this So one other way that you can do it is also trying to see the information in only one site, but now we are focusing in different years. And again, you can see here that you have some hybrids that they're constantly above. This is minor. And there is some hybrids that they are constantly below. So giving you this information, it's really important in terms of, okay, regardless the weather of the year, for minor, this hybrid behave better than the other ones. Saying this, there is some cases that you have some hybrids that, like this light blue one, that really changed the ranking based on the conditions of the year. So we know that last year was quite wet and the previous years were a little bit drier. So probably this hybrid have a different behavior because of that. So we have been talking about yield, and there is two concepts that are really important when we're talking about this, and it's yield potential and yield stability. Yield potential is when you want the hybrid that yields the most, and it's something that it's fair, like everybody wants that, right? But also another concept that's really important, and from a management of risk, it's also really important, is considering the yield stability. That is, that this hybrid, this practice don't change across different conditions. So it remains relatively stable. So saying this, there is a way that researchers study this, and probably this might be a lot of lines for you when I show you the graph that I'm going to show you later. So I will try to go slow. So in the previous graphs that we have been seeing, that I've been showing, in the x-axis, you always have the site. You have Minot, Langdon, Fargo, Hettinger, right? But also you can express instead of just a name, you can put a number. You can say which is the average of that, of all the hybrids on that specific site. And that gives you an idea of the environmental quality, at least the environmental quality in this year that we are showing. And in order just to show oil and yield at the same time, I just converted, and this is what I'm showing here is just the average oil instead of in concentration, it's pounds per acre. So it's just the conversion of the yield and the oil in pounds per acre. So saying this, we can see that here Hettinger had a lower environmental quality, and if we go to Minot, in the past year, it had a higher environmental quality. And now this is the figure that I told you, maybe it's too many lines, and this is the figure I wanted to show you. So basically what you can see here is that we have our 4 sites, that they're Hettinger, Fargo, Langdon, and Minot, and they are just all the hybrids that we were seeing before are just located under that environmental mean, environmental quality value that we were seeing. So Hettinger is just back here and Minot is just back here. And here, so we have the site average in the x-axis representing the sites, and in the y-axis we have the hybrid oil and the individual hybrids values. So what we can see here is that, okay, all the values of Hettinger are pretty much concentrated. There is not much difference between the hybrids. And then when we go to Minot, we can see that there is quite a variability here in terms of yield. And then what I was going to talk about today and for this slide is about the stability and potential, and I haven't forgot about that yet. Basically, what you can do when you drew this regression, these lines that shows the behavior of different hybrids in different sites, it's this. For example, if we highlight this hybrid, we can say that even though it's in Hettinger or even if it is in Minot, the yield actually doesn't change. So that means that this hybrid is more or less stable. So regardless the environment conditions. In this case, it's sites, but we could be analyzing different things as weather as well. When we're seeing this, is that we can say that, okay, this actually doesn't change much. But you also have other hybrids that, because of different traits that they have, they behave really differently. They have this kind of behavior here. I'm highlighting another hybrid. And you can see that in good conditions, this hybrid is one of the best. But when you are in lower environmental conditions, this hybrid drops a lot. So we say that the green hybrid here is it's stable, and this black hybrid here is adaptable. So it really adapts to the conditions that we have. So if you are aiming for yield potential and you want to strive to have the highest yield potential, probably you should go for an adaptable hybrid, but it's going to be a little bit more risky. And if, on the other hand, if you want to go to a more comfortable situation, you can check and use more stable hybrid. Saying this, there is, besides yields, there is other considerations that you have to take when you are choosing your hybrid. One of them is the maturity group. So there is this concept that says that later maturity varieties usually yield greater than early maturity varieties. And this is true. And there is just a really simple explanation for this, and it's radiation. So if we go back to Plants 101, you need only 3 things for a plant to grow. You need radiation, you need water, and you need nutrients. So you can deal with nutrients by fertilizing. You can deal with water if you have irrigation. But there is not really a sustainable way to deal with radiation. You cannot put an extra lamps or something in your field. It's not something real. But basically, the way you can deal or you can manage your radiation is through maturity groups, having later maturity varieties. Basically, what you are doing is having longer the plant in your field, and you have more time just intercepting radiation. It's just a matter of time. There's other ways also that are related to how we deal with radiation, with the energy from the sun that we need for our plants. And that's dealing with different plant populations or row spacing, that the fastest that you cover your interrow, the fastest that you are intercepting the most radiation possible. There is a lot of other things that they are actually interacting with this, and you should take into account. Sometimes yield potential is not your priority. Sometimes just having enough water to have a good crop during the whole season, it's more important than having yield potential. Saying that, there is another thing. First, I'm going to mention the comment that was dropped in the Q&A box that was regarding a farmer in Ontario. I think he asked that to Brady just because my logic was that the question was related that if there is a lot of leaching of nutrients because you have a lot of rains, and that was one of the things that might hinder your yields. And there is a lot of things going on, and I liked it to bring this concept, this question now, because we were talking about radiation. So basically, even if you don't have water deficiency, which is great, and we need that, you might have more cloudy days, and your average radiation might drop, and that might be one of the causes. Also, if you have different disease pressure, that might be one of the causes as well. Also, if we are thinking about a sunflower, sometimes having so many rainy days, it depends on when that happened. you might change a little bit the behavior of different pollinators. So that might be other things and that might be involved. But I should know much more about your situation, about your farm, to actually give you an answer regarding that. Saying that, I will continue. I just wanted to bring that here. One of the most important things when we are talking about the maturity of the varieties is the risk of a frost. So it's really important. It's better to have an early maturity than a later maturity if we are putting our crop in the risk of being impacted by a frost. Thank the National Sunflower Association for sponsoring this program and making this possible.